So tell us your names and major.
My name is Jessica White, and I am an accounting major.
I'm Ashley Hogan, and I'm a film and theater major.
So you want to tell us about your poster?
Sure. Okay, so we have geothermal energy, which is geothermal energy is using the heat of the earth to create energy or cool and heat homes. So this is a map of the potential of geothermal energy across the U.S. And the potential is greater in the west because it has a greater heat underneath the earth because of the tectonic plate. And in Georgia, it's a lower temperature, so the potential isn't as great. But technology is advancing to where we're starting to try to find ways to get geothermal energy in Georgia. And one of those ways is an enhanced geothermal system. And that involves injecting cool water into a hot reservoir that creates steam and turns the turbines to create energy. One way to save energy is by using a geothermal heat pump in homes and businesses. So that involves digging a pipe about 10 feet underground, which it remains about 50 degrees year-round at 10 feet. So you can install a pipe and pump water, refrigerants, or air through it to heat or cool your home, depending on whether it's summer or winter. And horizontal loops are good for businesses because you get parking lots, you get wide spaces, and then for residential areas, you can go dig deep down. Or you can save money because you don't have to dig as much if you have a nearby water source, and you can install it in one of those.
And geothermal energy is a renewable resource. That means that you can keep using it. You're never going to run out, and you can reuse it as well. And it actually has the largest capacity out of all other renewable resources, and it has a capacity of 5,000, which is energy per unit time. And the future of geothermal capacity and production is projected to grow immensely from about now to 2050. And with this, it will be after research and development happens, and they are able to find a more efficient and costly way to extract the heat from the earth at lower temperatures, such as Georgia and other places. And if Georgia were to start using geothermal energy, then if 5% of the homes in Georgia started using geothermal energy, which is 175,000 homes, it would reduce the amount of CO2 emissions in the air by 355,000 tons, which is equivalent to 35 million trees being planted or taking 350,000 cars off the road.
And the geothermal heat pumps, they're costly at the beginning because the actual system costs about the same as a heating or cooling system, but what costs so much is digging underneath the ground and installing pipes. But it's predicted that you can save or pay off for it within 2 to 10 years. Based on the savings you get. And this is the efficiency of them. And this is the geothermal heat pumps, and these are regular furnaces, and that's just standard geothermal. So it's much more efficient, and there's no emissions, and there's really no environmental effect of geothermal heat pumps.
You want to tell us something interesting you took away from this project? Something you learned
What I found so interesting was just the amount of things that will be reduced. It's just the savings that it will generate, and basically how beneficial it will be to us once we start using it, and not having to depend on non-renewable sources such as coal and other things like that.
I had never heard of geothermal energy, so I found it really interesting, and the fact that how renewable it is, and I didn't think there was really anything better than solar power, but as this clearly shows, it's much better and there's even less emissions from it. So.
The Okefenokee is a freshwater swamp, and these are the cypress trees, as Elise mentioned.